Hi everyone, this is my Gameboy Zero, which I made myself. It's there's a few of them out there now, so I'm not going to really go much into this. This is the second one I made after the first one I accidentally managed to drive over with my car. So yeah, it fell out of my pocket as I was putting my son's seatbelt on. I hadn't noticed, went to pull away, and then crunch. But anyway, we're not here to talk about this. We're here to talk about power requirements of a Game Boy Zero. Now, a lot of people have said, "Oh, well, the Game Boy Zero or the Raspberry Pi Zero needs approximately 600 milliamps to use, or this, that, and the other." And a few people have speculated how much it does need when you combine it with the screen and the amplifier and everything else. But I have to say, I'm seeing a lot of conflicting reports. People will argue that it needs this amount. Somebody else might say it needs this amount. What I would really like to see is a video where somebody can actually hooks up one of these to a giant comedy ammeter or amp meter, and really just demonstrates how they work. Well, luckily, guess what I've got? Here's a Game Boy Zero, and here's a ridiculous ammeter. This is actually a 1960s Farnell power supply, as you can see there. Yeah, so this is over 50 years old. It was found in a skip, or a dumpster if you're American. Yeah, and it actually works pretty well. What I'm actually doing here is I've got this set for amps. As you can see, there's no amps, so I'll switch this over there. You can see it's drawing just over 4 volts. Now I've hooked it up to a modern multimeter here, so you can actually see the correct volts. I've got it about 4.1 volts. I think what I might do is actually just eke that up a little bit, just to just eke that up to about 4. Let's go for 4.3. Yeah. So we're gonna simulate a fully charged battery here. So at the extreme end here. So yeah, so that's there. But we're not interested in volts on this meter. We're interested in amps, or parts of amps anyway. So as you can see, I've got this hooked up to my Game Boy Zero. So let's fire it up and see what it is. Right, okay, this might take a bit of this might be a bit difficult here because I'm actually holding the camera as well as this. So what I'm going to do is see if I can do this one-handed. Well, it boots up, and we'll see what it does. Let's see if I can move that off a bit there. It's interesting to note you can see the needle bouncing around there whenever it completes a process or it starts a process. Yeah, let's just see what it's going to do. Now, my main worry here is this power supply as you can see, only goes up to 500 milliamps, or half an amp. And people seem to think that these Game Boy Zeros require at least 600 milliamps. So that's going to be interesting. It's just loading emulation station now. You can see. Yeah. It's interesting how it's sort of just over 400 milliamps there. You can see. Oh, and reloaded. Have a look. Dare I start a game? Let's try something easy. Let's try the Game Boy Color version of Tetris. Let's see what it thinks of that. Alright, let's just... Ooh. Alright, so... Now, you'll notice I've got the sound off here. There's a reason for that. Yep, let's go for it. Right, I'm actually playing this one-handed here, so this could be interesting. But yeah, you see, in use it seems to be. Yeah, yeah, it's interesting how long you can see. You can see it sort of jumping. Yeah, so it's just about 3.5. Oh, hang on, let's get that. 3.5 to. Yeah, sort of. Yeah. Whenever I press the button, because this is actually GPIO pins, you can see the needle moves a little bit, but not much. So yeah, so about 350 milliamps that's using. Occasionally, yeah, depending on what the game's doing. Yeah, so when the game ended, there you could see it hovered up to about a thing. Now, I'm really worried about this because I know with the sound it can just oh there we go. Yes, yeah. And the power's down, yeah. Hang on. There we go. So that just peaked over 600 there, but it was only short though.